Hey everyone, let's dive into something that's at the absolute heart of the Spring framework, dependency injection. This is one of those concepts that, once you get it, completely changes how you think about building software that's easy to change and manage. So let's get right to it.
You know that feeling, right? You're trying to make one tiny change, and boom, a dozen other things break across the application. It's incredibly frustrating. Well, that exact feeling, that brittleness, is usually caused by a problem that dependency injection was born to solve. So, what's actually causing that headache? It all comes down to a problem we call tight coupling. That's when all your different components are so tangled up with each other that you can't touch one without affecting all the others. And before we can really appreciate Spring's solution, we've got to understand the problem it's designed to fix.
Imagine your code is like a machine where all the parts are literally welded together. If you want to replace the engine, you have to get out a blowtorch, cut through the welds, and then weld a new one in. It's messy, it's risky, but with loose coupling, it's a completely different story. It's like playing with Legos. Every brick is its own thing, and you can just snap them together or swap them out whenever you want without breaking the whole structure. That's the dream.
All right, to really get a handle on this, let's step away from the code for a sec and use a super simple analogy that I think makes this crystal clear. We're going to talk about cars.
I mean, this is just a fact of life, right? A car needs an engine to do its job. Without one, it's just a big fancy paperweight. And it's the exact same thing in our software. Our code objects often need other objects to be able to do their work.
And that's a perfect mirror for what happens in our code. A car object can't function without an engine object. So in programming terms, we say the car has a dependency on the engine. It's a critical relationship.
Okay, so the car needs an engine. That's clear. But here's the million-dollar question. Where does it get the engine from? And how? In a tightly coupled world, the car would have to build its own engine from scratch, right there on the assembly line, and fuse it directly into its frame. And you can see how rigid and inflexible that would be.
And this is where Spring just completely changes the game. This is where we meet the hero of our story, the Spring container. It's the mechanism that solves this whole problem for us.
This whole idea brings us to the core pattern we're talking about today, dependency injection, or DI for short. The idea is simple. Our car component shouldn't have to worry about building its own engine. No way. Instead, some outside force, some external entity, will provide or inject a fully built engine right when the car needs it. So who is this mysterious external entity? Well, it's the Spring IOC container. Now, IOC stands for inversion of control, which sounds complicated, but it's not. It just means we're flipping the script. Instead of our code being in charge of creating everything, we hand over that control to the Spring framework. That's why thinking of it as a smart factory or maybe even a master mechanic is the perfect way to picture it.
So how does this magic actually happen? It's really just a simple three-step dance. First, your car class basically just raises its hand and says, hey, I need an engine to work. You might do this with an annotation like add auto wired. Second, the Spring container, which has already scanned your code, says, I gotcha, and it builds and manages an engine object, which Spring calls a bean. Then finally, when your application needs a car, the container just takes that engine bean it made and injects it. The car gets exactly what it needs without ever knowing or caring how the engine was built.
Okay, so that's the how. It makes sense. But now for the really important part. Why do we do this? What's the big win for us as developers? Why is this so powerful? The payoff is huge. And it really all comes down to these two massive benefits: unbelievable flexibility and fantastic reusability.
Let's dig into that. Flexibility? Imagine you want to upgrade from a V6 gas engine to a new electric motor. With DI, you don't touch the car code at all. You just tell the Spring factory, hey, from now on when someone asks for an engine, give them this electric one. It's that simple. And reusability? Once that factory knows how to build that engine bean, it can pop that same engine into a car, a truck, a van, whatever needs it. You build it once and reuse it everywhere. And this makes testing a dream, because you can just tell Spring to inject a mock engine to test your car in total isolation. It's a game changer.
So if we boil all this down to one single, massive takeaway, what is it? It's about fundamentally changing who is in charge of connecting all the pieces of your application.
It's this right here. This is the whole mantra. You declare what your components need, and the Spring framework takes care of all the messy wiring, the assembly, and the entire life cycle of those objects for you.
And what does that mean for you? It means you get to stop being a plumber. You're freed from worrying about all that low-level stuff, how things get created, how they get connected, and you get to focus your brain power on the fun part, building awesome features that your users will actually love.
So I'll just leave you with this question to think about. Now that you have this incredibly powerful framework handling all the complex wiring for you, what amazing things are you gonna build?